Hey, welcome. I want you to just take a second and look around you. Everything, I mean, the air you're breathing right now, the device you're watching this on, it all has a place on this giant invisible map that scientists use. So we're going to go on a little journey and actually build that map together. A map that organizes pretty much everything in the entire physical world. Okay, let's dive right in with a question that, sounds kind of weird at first. What could possibly connect the totally see-through air all around us with a cloudy glass of milk? They seem like complete opposites, right? Well, the answer is just one simple word. They're both mixtures. Yeah, seriously. That one word, mixtures, is our first major landmark. It's the starting point for this whole incredible map of matter. So, every good map has to have a starting point. For us, that's this huge concept called matter. And right away, we come to a massive fork in the road. We have to make a choice and split everything that exists into one of just two categories. But hang on, what even is matter? It's actually super simple. It's anything that has mass and takes up space. So, a chair, a glass of water, and yep, even the air. If you can weigh it and it fills a volume, it's matter. Okay, so here's that split I was talking about. All matter, everything, falls into one of two teams: pure substances or mixtures. Now, a pure substance has a fixed, unchanging identity. Think of it like a sports team, where every single player wears the exact same jersey. But a mixture, that's more like a trail mix. You can have different ingredients, you can change the amounts, and you could, if you really wanted to, pick the pieces apart. So let's take a quick detour down that first path on our map. What exactly are these pure substances? Well, they come in two main flavors. First, you've got elements. These are the absolute most basic building blocks of the universe, like a bar of pure iron or a tank of pure oxygen. Then you have compounds. This is where two or more elements chemically lock together. And here's the wild part. When they combine, the new compound, like water, H2O, has totally different properties from the elements it's made of. It's like this chemical teamwork creates something brand new. All right, our little detour is done. Let's get back on the main road and dive into the much more varied and frankly more complex world of mixtures. So, inside the land of mixtures, we hit another fork in the road. On one side, you have what are called homogeneous mixtures. That's where everything is so perfectly and evenly mixed that it looks like just one thing, like sugar dissolved in water. But on the other side, you have heterogeneous mixtures. Here, you can clearly see all the different parts, like a handful of sand swirled around in a glass of water. And this is where our map gets really, really interesting. Because as we zoom in even closer, we find that mixtures are sorted into three main families, and each one has its own totally unique personality. They're called solutions, colloids, and suspensions. So let's meet the family. First up, you have solutions. Think perfectly mixed particles so incredibly tiny they never ever settle out. Saltwater is a classic example. Then you have colloids. This is the fascinating middle ground. The particles are bigger, which makes the mixture cloudy, but they're still light enough that they don't sink. Milk is our poster child here. And finally, you have suspensions. Here, the particles are big, they're heavy, and they're just waiting to give in to gravity and sink right to the bottom, like muddy water. Okay, so they're all mixtures. What's the one big secret that makes them behave so differently? This is the real aha moment of this whole explainer, I promise. So what is it? What's the single most important factor that puts them in these different boxes?
The answer is so beautifully simple, it's almost hard to believe. It all comes down to just one thing: size. That's it. The size of the particles mixed in there determines everything.
This chart just lays it out perfectly. In a solution, the particles are basically the size of molecules, impossibly small. In a colloid, the particles are a little chunkier in that medium range. And by the time we get to a suspension, the particles are legitimately large and distinct. This one difference, small, medium, large, is the secret code to understanding all of them.
In fact, get this, that medium particle size in colloids creates this absolutely stunning visual effect called the Tyndall effect. It's the reason you can see those beautiful sunbeams cutting through a foggy morning. It's also why milk is white instead of clear. Those medium-sized particles are just big enough to catch beams of light and scatter them in every direction. It's pretty cool.
So, with that final, super important piece of the puzzle, our map of matter, well, it's pretty much complete. So let's look at our final field guide. From now on, you can identify any mixture just by asking a few simple questions. Does it look clear? Are the particles tiny and never settle? Boom, you've got a solution. Is it kind of cloudy, but the bits stay floating around? That's a colloid. And if it's murky, and you know those chunky bits will eventually settle and you could filter them out, that's definitely a suspension. And what's so amazing is that you are living in a world of colloids, and you probably never even realized it. I'm talking about whipped cream, fog, smoke, mayonnaise, jelly, even paint. All of them are these complex, fascinating colloidal systems that we see and use every single day. And that's the real power here, isn't it? With this simple mental map, you, yes, you, can now look at the world around you with the eyes of a chemist and understand the very substance of reality in a whole new way. So I'll leave you with one last question to chew on. After all of this, after learning how scientists classify everything, what do you think is the most complex mixture that you personally encounter every single day? Think about it. The answer might be closer and a lot more personal than you think.